Now, in a situation where the angle isn't 30, 60, or 45, they're going to be presenting you like this. All right? They're going to tell you that sine or cosine equals something, ask for the other one. Now, one thing I will mention on this scenario is this. Cosine is the horizontal dimension, sine is the vertical dimension. We have to know what quadrant we're in. All right? It's very important we have to know a quadrant. So, cosine is positive here, cosine is positive down here, cosine is negative over here, cosine is negative over here. If I'm going horizontally, if I'm in the first or fourth quadrants, I'm going to be going right, which is positive. If I'm in the second or third quadrants, I'm going left, which is negative. And cosine, again, is the left or the right. Right? So as soon as I see cosine of theta is equal to negative 3/5, that tells me immediately that I'm in the second or third quadrants because cosine is negative. Okay? Sine is positive in the first and second quadrants, and sine is negative in the third and fourth quadrants because sine's the vertical dimension. If I'm going up, it's positive. If I'm going down, it's negative. So again, it's very easy to establish signs, positive or negative signs, on these two trig functions. So it tells me that the angle has measured theta in quadrant 3. So the quadrant 3 is where we're at. So they told me quadrant 3, that's how I know I'm in quadrant 3. So if I draw a picture of this, I'm in quadrant 3. The angle they're giving me, theta, is always measured in standard position. So I'm here, around to there, there's theta. Cosine is negative 3/5. My task is to find sine. Okay? The only thing I can't find with the formula I'm about to give you is the sign of the answer. I don't know if it's positive or negative using my formula. But I know it's positive or negative knowing what quadrant it's in. Now, there's two ways they can present the quadrant to you. One is saying, hey, it's in quadrant 3. We'll call that the easy way. The easy way, here, you're in quadrant 3. How do you know you're in quadrant 3? Because it says right there we're in quadrant 3. That's the easy way. All right, the more difficult way, still not hard. This is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, this is 360 degrees. If you don't remember those numbers, just keep adding 90. What's 0 plus 90? What's 90 plus 90? What's 180 plus 90? What's 270 plus 90? Just keep adding 90, right? So that's how you find those numbers. The other way they might tell you is they might say this. They might say 180 degrees is less than or equal to theta is less than or equal to 270 degrees. That's another way of saying quadrant 3. Theta is between 180 and 270, so that puts it in the third quadrant. They might go crazy hard on you. They might say this. This is 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians. This is 2 pi radians. Okay? Start with 0. Keep adding pi over 2. 1 pi over 2. 2 pi over 2 reduces to pi. 3 pi over 2. 4 pi over 2 reduces to 2 pi. They might say this. Pi is less than or equal to theta is less than or equal to 3 pi over 2. That's another way of saying the third quadrant. So they'll either tell you in quadrant 3, they'll say you're between 180 and 270, which is quadrant 3, or they'll say you're between pi and 3 pi over 2, which is quadrant 3. The necessity is what quadrant you're in. That's what you need to know. You know what quadrant you're in, you can find your answer. All right, so here's the magic formula that we're going to use. If I know cosine, I want to know sine, or if I know sine, I want to know cosine. I have to know the quadrant, so that's a requirement. So make sure that's priority 1. What quadrant am I in? All right. Here's the formula. Sine squared of an angle plus cosine squared of the same angle always equals 1. I have no earthly idea what the angle here in this problem is. I don't know. It doesn't matter what the angle is as long as the angle is the same angle, which it will be. It says cosine equals this, find sine of the same angle, right? If I substitute what I know into this formula, which is always true, cosine equals negative 3/5, it looks like this. Sine squared of theta, don't know that yet, plus parentheses negative 3/5 end parentheses squared equals 1. substitute what you know. Cosine equals -3/5, cosine's being squared. So I take the -3/5 that cosine equals and I square it. What happens when you square something to the sine? Always positive, right? So -3/5 squared just means 3 times 3 on top is 9, 5 times 5 on the bottom is 25. Like so. And again, it's always positive. It doesn't matter if it's positive or negative. When you square it, you get a positive there. Now my task is to find out what sine equals. So I want to get this to say sine equals, right? So first I have to get sine squared equals. So this is 9/25. Would everybody agree? If you don't agree, let me know and I'll have a talk to you about fractions. But one's the same as 25/25. And the reason 25/25 is better than 1 is because I have a fraction I have to subtract. I need a common denominator, right? So if I want to chop this 9/25 off here, move it over here, it's better that that 1 is in 25ths form than it is in 1 form, right? So 25/25 minus 9/25, that gets me to sine squared of theta is equal to 16/25. If sine squared equals anything, to find sine, I'm going to square root both sides, right? So sine squared equals number. Sine is going to equal plus or minus the square root of 16/25. Very, very important. Anytime you have anything squared equals number, when you square root that thing, you are required to put the plus or minus there, because it could be either one. And I think we all know how to take the square root of a fraction, especially when the numbers are friendly like this. Square root of a fraction is simply the square root of the top. The square root of 16 is 4. The square root of the bottom, 25, is 5. So sine could either be positive 4/5 or negative 4/5 based on that formula. This formula right here, that is 100% of the time true, always, forever, every angle. Always works. No matter what the angle is, it always equals 1. So, which one should I take?
Negative.
And why would I want to take negative?
Because it's in quadrant 3.
Because we're in quadrant 3. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. We are finding sine. It says find sine. In quadrant 3, sine is negative. If we were in quadrant 2, cosine would still be negative in quadrant 2, but now sine's positive. So again, negative sine, positive sine. It depends on where you're at. So because we're in quadrant 3, we're going to throw out the positive 4/5. The correct answer to the problem, sine of theta would equal negative 4/5 for this particular problem. It's got to be one of the two numbers. You just have to pick the right one. And again, where you're at establishes what the right one is. Think of cosine as the x-coordinate, sine as the y-coordinate. What direction are you going? X positive, right, x negative, left, cosine positive, right, cosine negative, left. Y positive up, y negative down, sine positive up, sine negative down. Okay, direction you go establishes the sign, plus or minus sign on these numbers. All right? That's how you establish that. Again, this is a very necessary rule to know in trigonometry. That's one you want to commit to memory as soon as possible. It's 100% of the time true, always true. No matter what the angle is, it always adds up to 1.